I paid a grand total of £45 for this faulty Xbox One S that I bought off eBay. The listing basically stated it's an Xbox One S, it's tested to be found faulty, good cosmetic condition, which I completely agree with, but it does not power up. And it's my job to see why that is. And to ditto what they've said in the description, this console is in great condition. There's no markings, there's no drawings, there's no nothing. It's pretty pristine. That also comes with a word of warning. In my small amount of experience fixing consoles, the cleaner the console is on the outside, the worse the fault is on the inside. Let's give it a test, give it some power and see what's going on, shall we? So plug that in. Do we get anything when we go to power it on? We do. It just beeps, but we don't get anything on the button. There's no light. So something is, I believe, shorting this out before it even registers a chance to turn on. I told you, I think this is going to be an interesting one if I'm honest. And I'm recording this when the UK is very hot. I can see it does look like as well. It's been opened before. The sticker has gone. Wow, look at this. Look how clean this is. Remember I said about it just being clean? It's not, it's like no dust whatsoever. It came out of the factory in 2018. So again, just not even that old. Oh, wicked. We've landed ourselves a 1 terabyte drive, even though it was listed for 500 gig. Things you love to see. So technically, even if we can't get this working, we can recoup a little bit of our money back. Before we get too in depth, I'm just going to try a different power supply. This one is one that I know that works from a donor console, because if that was the issue, that would be funny. Let's plug it in. Okay, what happens? Still the same thing. No light, nothing. Just as soon as we press the button, it turns straight back off, or essentially doesn't even turn on. First things first, we've got the meter in continuity mode, which is the mode that beeps when we have a complete circuit. And I'm going to see if we have a short on the 12 volt rail, which I don't think actually we're going to have. So I should get a beep here if it's shorted. And no, we don't get a beep. So it means that the 12 volt rail on this machine is fine. I kind of suspected that because it attempts to turn on and we get the beep from the speaker. I think there will be, but next I'm going to measure on the MOSFETs. I've put the meter into diode mode and I've put the red probe, as you can see, on ground. And we're going to read the gate on the MOSFET and we should get 0.6, which we do for the first one. That's really good. I'm just going to go down here now and check these. 0.6, that's good. That's normal. 0.6, normal. 0.6 normal, normal, and the last one, normal. So the 12 volt line here seems to be a-okay. I've had a quick visual inspection on the board and I can't see anywhere where I think there might be an issue. In fact, I'd actually go to say that this board is cleaner than the outside of the Xbox. Even on the back, nothing. Nada. Now we're going to have to use the test points on the board to measure the voltages that come in through the power supply. That might be able to tell us what power line is causing the fault. So straight off the bat, do we get 12 volts on the power rail? Yes, we do. 11.94. That is suffice. That's a good amount of power. Do we have the 5 volt, which is over here on this test pad? Yes, we do. We've got the 5 volt. Do we have the 3.3, which is this test pad? Yes, we do. We've got 3.3. Do we have 1.8? We have 1.8. And finally, do we have 1.1? We do. We've got every single voltage on the board. This now makes everything 10 times harder. So you might now be thinking, Joey, what's the next step? What are you going to do? I'm going to take a thermal cam, a FLIR thermal cam, and I'm going to plug it into my phone. And what we're going to do is we're going to turn the board on and see if anything gets hot. The indication of heat may give us the source of the short, if there is one, which I'm assuming there is because it's not turned on. So I've got my FLIR cam at the ready. So I'm just going to power it on and see. Oh, wait a minute. We get a light now. We get a light on the board, and that's okay, and it turns off. That's going to overheat though because we don't have anything on it. Well, how strange. Let me put some of it back together, I guess. Maybe there was something shorting out the board. Could even be the fan, to be honest. We'll leave just the fan in for the time being and see if we get the same result. Is it going to be okay? Let's have a look. No, the light's not coming on. How strange. What, so it's the fan? I'm going to unplug the fan. The fan is now unplugged. Now what happens? Still nothing. We've gone back to the same problem. Is it potentially pressure on the APU that it's not liking? So if I just take that off and remove it, and then remove the board, and now we just try it again without having that pressure on the APU, is that what it is? Do we have like a bad APU? So I'm going to push it now. No, it's not coming on. I don't understand. Okay, back to the thermal cam. I'm now recording on my phone. This is the FLIR cam. You can see the APU is really, really hot, but I'm going to turn it on now. The light has come on again, and as you can see, the south bridge heats up, and we also get this massive bit of heat here. That's what I'm going to be interested in, because we have the APU going hot, it's just turned off. We have the south bridge getting hot, but we also have this area here, right here. So I'm going to focus my attention around here. We're now on the microscope, and I've marked the suspicious component, I'm going to say, with yellow Sharpay. Now, on the face of it, this doesn't actually look too bad. I don't know, this cap to me looks a little bit sus. If I kind of change the board view here, I don't know, the cap, it might be the cap where all that heat's coming from. What I'm going to do though is I'm going to try and power it on again. I'm going to put some isopropyl alcohol on the board, and we're going to see what melts first. So you ready? Because it's now turning on for some reason. Here we go. Oh, it's definitely that component. See how hot that component got? I'll show you guys again, ready? Look at this. I mean, I'm just dropping it on. Look how quickly it dissolves. Where the gold is. And now it's turned off. It's fine, but let me just do it once more. Ready? Here we go. Turning it on now. Look how hot that gets. The whole area kind of gets hot, to be honest. But that component, more so than anything else. I think then, by the rule of thumb, I think we're going to get rid of this component and swap it out for another one and just see if that is what's causing the issues when we're trying to power it on with all the hard drive and disk drive, etc. in. I don't know, it's the only thing getting hot on the board, so let's give it a go. This is the component on a donor board, this one here, U5D4, so let's get it off. 450 degrees Celsius with an airflow speed of 50%. Could go higher to get it off, to be honest. Right, let's get this one removed from existence now. Nice, we'll just put it to the side. Get some flux on the board. Get some leaded solder on the iron. Prep the pads. Tip that I'm using is a bit too big for this, but now hot air, we're going to put the speed down to 30%. Put a little bit of flux. I'm going to push down. There we go, solid connection. Tiny bit of flux here. Take the iron just to get that ball out. There we go, nice. And you guys know it's now my favourite part, which is to clean it with isopropyl alcohol. I don't know, something about it's just really therapeutic. Really therapeutic. Like nothing ever happened. Nice. Let's give it a test. I think I knocked my monitor, which is now it's a little bit wonky. First things first, do we get power? No. We get no power. So that has done nothing, I think. Exactly the same thing. Okay, wait, now I've got power. Okay, I'm gonna turn it off. APU is very hot. Let's put the fan back on. Okay, fan's plugged in. Do we get a fan spin and anything when it turns on? Still nothing. If I get the flare cam out, do we have the same areas that are still getting warm? Yeah, the exact same area. So I actually think that component was okay, because that area is still, it's now showing 43 degrees. But the south bridge has got like a massive burn on it. It's on, the machine's turned on, there's a white light, but we don't get anything fan related. Nothing's like registering the fan, it's just turned off. Nothing's like prompting the fan to work, you know? I've just turned the machine on again, you can see from the light, and it's just turned off, but south bridge, again, very, very hot, along with that same component that we replaced. Okay, this is a tricky one. I don't want to just write it off and say, oh, it's the south bridge, but I'm going to do a little bit more digging to see if there's anything else that could potentially be the cause. I was just doing some testing around here in continuity mode, again, the mode that beeps when we have a full circuit. Capacitors usually have one side that's grounded and the other side with a reading. This one, however, is a little bit different. This one here is a good example. This side should be ground, which it is because we get the beep. This side, we shouldn't have a beep, which we don't, because it's basically doing something useful. This capacitor down here, we have a short on this side, and we have a short on this side. When I put the meter into diode mode and measure this resistor, we get 0.4 on this side and we get ground on this side. My guess is that this isn't meant to be ground. This whole pad here isn't meant to be ground. I've just put the meter into diode mode, and what I should get, this is a test pad for 3.3 volts. If I put red probe on ground this time and use the black probe, I should get a reading here of around about 0.6 or so, but I get nothing. I get 0.00. If I put the meter back into continuity mode and measure each side of the cap, we get a beep. That usually means that this capacitor here has gone bust. I'm going to swap this over from the donor board and see if that makes a difference, as that could be causing this chip right here to play up. Let's get this little guy off the board. Add this little guy to the family. little bit of flux. Give it a nice clean. Lovely jubbly. Look at that. Meters in continuity mode. Do we still get a beep? Remember we did before? We do. Okay, interesting. I should have tested it when it was off the board, shouldn't I? So we still have a short to ground on this pad somewhere on the 3.3 voltage rail. Right, let's take it off the board again, shall we? I've removed the cap and I put the power supply back in. I don't know if that's going to alter the readings whatsoever, but if I measure this in voltage mode, I get 35 millivolts. And I should be getting 3.3 volts. So I'm thinking the next stage is to inject some heat on here and see if that brings anything up. I started off injecting 1 volt and I was drawing 2 amps straight away. So I've put up to 3 volts and I'm drawing 3.1 amps. But nothing is getting hot on the board other than the APU, which I'll show you in a clip now. I'm injecting voltage, and as you can see, the back of the CPU, this is the back of the board, the back of the CPU is the area that's getting really hot. I'm going to inject the 3 volts now onto the 3.3. Now I'm actually drawing 4 amps, but as you can see, nothing on the board is getting hot except for the APU. And can you see there's like a line, there's like a heat line that goes to where I'm pointing my probe? So I have a feeling that that 3.3 rail goes to the CPU, and I think the CPU is fried. I think that's my conclusion. For my own peace of mind, I'm actually going to remove this component here and see if we still have the issue on the 3.3 line. Because we've got rid of this cap now, I might as well take off all the components and see if anything is causing it to play up, which I doubt, but you never know. Do we still have a short to ground on the 3.3? Yes, we do. I'm just going to remove this little resistor here. Has that made a difference? No. We still get a short to ground. There's no components here anymore. I personally think this is linked directly to the APU over this side, and that's what's causing it to short. Based on my findings on the board, I'm pretty happy guessing that it's the APU at fault, seeing as that's the only thing that gets hot when we inject voltage to that 3.3 rail. The other 3.3 rails are fine. It's just that one that's playing up, just that area. And I think I've done a good amount of diagnosing before I call it quits. It's a shame because I really thought that that cap had gone and that would have fixed it. I really, really thought it would. Nevertheless, I've learned something today. If you have any other information about this specific repair, then please feel free to drop it in a comment down below. Thank you so much for watching. If you did enjoy it, hit the thumbs up button and subscribe to the channel if you're new around here. Have a great rest of your weekend, and I'll see you in the next one. Peace.